Hi guys, so we are going to work on section 10.5 today, which is inscribed angles. So you should have your note sheet that looks just like this out and ready to go. Before we get into inscribed angles though, I did want to take some time to review a couple of concepts that we'll need for this section. So if you were part of the central angles 10.3 lesson and you saw the 10.3 lesson and you did the IXL, then you can probably skip over this portion that I'm going to review. But if you were not here for it or you want the nice review, then you can just sit and listen. There's no notes to copy along with this. It's more just a refresher that you can work through and listen to remind you of some key components about circles and about lines in general. So these two questions come straight from the section 10.3 notes. I just wanted to review them again really quick and highlight the fact that all circles add up to 360 degrees always. No matter how many angles there are, no matter how big the circle is, no matter how small the circle is, the sum of the angle measures will always, always, always be 360 degrees. So in these two examples, when we're looking for a missing part of the circle and we're dealing with central angles or the arcs of central angles, the steps are fairly simple in order to find that missing part. So I know that arc DF for problem 1 is 110 degrees. I know that arc DE is 140 degrees. And then I'm looking for arc EF. I don't know how long this is. I need to figure out how long this is. So in order to do that, I know that part of the circle is 110 and another part of the circle is 140. My first step is I want to add those together. So when I add those together, I get 250, but then that's not my answer. That's what this whole section equals. So to find that missing part EF, I have to do 360 minus 250, and then that would give me 110, which is my answer, 110 degrees. So this is a concept that we'll use for section 10.5, so I did want to make sure that we had time to review it. Now the same thing is true with number 2. It doesn't matter if we're looking at the arc or at the central angle because we're talking about it in terms of degrees. We're not looking at arc length like we were in 10.4. We're focused back on that degree concept. So now again, I have 3 central angles here. I have this guy. This would be my first central angle. This guy, another one, and then a third. And I don't know the measure of that third central angle. So what I can do is I can add up the measures that I do know. So I have an angle that's 70 degrees and an angle that's 150 degrees. If I add those together, I get 220 degrees. And that's what this whole portion of the arc is equal to. So in order to find the measure of that third angle, I would have to do 360 minus 220. And I get 140 degrees. All right, so that's the basic concepts. These are from section 10.3, but we will use it occasionally in today's lesson, so I did want to make sure that we took some time to review it. Now, something that you haven't seen in quite some time is a guy like number 3. So looking at number 3, this is actually a flashback to chapter 1. So think all the way back to the beginning of the year, September, October-ish. This is what we were talking about in chapter 1. So if we look at this, I don't know if anybody remembers the key term, but I have a straight line that's split up into 2 angles. So that I would call a linear pair. So a linear pair consists of 2 angles that are next to each other. They share this common side and that add up to 180 degrees. And anything that makes this straight line, remember, always adds to 180 degrees. So we are going to use that today as well. So in number 3, I want to find the value of x. So let me just fill in, add to 180 degrees. Again, you don't have to take any notes. This is just to refresh you. So I want to find the value of x. In order to do that, I know that this entire angle is equal to 180 degrees. So it's a similar concept as numbers 1 and 2. It's actually a little bit easier. So if the whole angle is 100 degrees and this part is 124, in order to find that missing part, I just have to do 180 minus 124. I'm borrowing 6, 5. So then I get that this guy is 56 degrees. So linear pairs, they've come back this whole time, but they do keep coming back throughout the remainder of geometry. So this is just a little refresher before we actually get into the lesson. All right, so now we're going to talk about inscribed angles. So this is a term that you haven't really heard before. It wasn't in your little cheat sheet because it's an extra component that I wanted to save until now to talk about. Now, before we get into inscribed angles, I am going to remind you once again what a central angle is. So remember, most importantly, that a central angle looks something like this guy. So it's an angle with a vertex at the center and two sides that are radii. And then the sum of all central angles, as we just talked about on that prior slide, of any circle is always 360 degrees. Doesn't matter how many central angles there are, how big the circle is, how small the circle is, it will always be 360 degrees. So now that we have that in mind, we're going to introduce inscribed angles, which is a new concept. So an inscribed angle is an angle with its vertex on the circle and two sides that are chords. So the key difference between an inscribed angle and a central angle is that central angle has a vertex at the center. So it looks here, so to speak, whereas an inscribed angle has its vertex on the actual circle. So every point from that angle is actually touching the edge of the circle. Now, there's a relationship between inscribed and central angles. Now, the relationship is that the degree of an inscribed angle is always half the degree of its corresponding central angle. Now, it's important, it's not just any central angle, it has to be the corresponding central angle. So I felt like the easiest way to explain what a corresponding central angle was with a picture. I don't know why it came out so blurry, so I'm sorry about that. But if we kind of look at this picture in the bottom, it's pretty clear what the inscribed angle is and what the central angle is, right? So that inscribed angle would be the purplish pinkish one, which I can label as angle ADC. So I know that angle ADC is an inscribed angle because all of the points on that angle are touching the edge of the circle. Now, its corresponding central angle, it's the only other angle given, it would be that blue angle, angle ABC. But it's very important to understand why it's that corresponding central angle. Now, the reason why angle ABC is the corresponding central angle to angle ADC is because if you look, they both have the same arc that they map to, right? They both map to this arc AC here. And if you look, angle ADC has edges at A and edges at C. Angle ABC meets at A and meets at C. So they share those points, they share that whole arc, so that would classify as a corresponding central angle. Now, because I know that these two coincide, I then know that angle ADC, the measure of angle ADC, I should say, is equal to half the measure of angle ABC. So I know that that gets a little confusing, so I'm going to pick numbers. So let's say that the measure of angle ABC is 80 degrees, right? So the measure of angle ABC is 80 degrees. The measure of angle ADC is not also 80 degrees. If you look, it looks like it's kind of squeezed closed more, right? So the measure of angle ADC is actually half ABC. So if this guy is 80 degrees, then this guy would have to be 40 degrees. And vice versa. If I started with the 40 degrees, then I could multiply it by 2, and I would know that that bigger angle was 80 degrees. All right? So we're going to get into some examples. So what I did when I did these examples, you'll notice they look like IXL. They come straight from IXL. What I did was I went through the entire IXL, and I tried to find every different question type that you could be asked. So although your numbers might look a little bit different and maybe the circles kind of spun a little bit, this generally looks like what all of your questions will look like. So I tried to give you as much variety as you could so that you wouldn't have any questions, you wouldn't see something and feel like it came out of left field. So if you do feel like you see something and you're like, wait a second, that doesn't make sense, just stop and email me. Please don't spend like an hour and a half working on the IXL and going through hundreds of questions just trying to get to 60, 70, 80, whatever it is, because I can help you. We can go through it together. It's not meant to be something that takes you an hour and a half. So if you feel like you're taking too long, please reach out and we can go through it together. Okay, so the directions say to find the measure of each angle below. So I want to find the measure of these angles. So the first one says, what is the measure of angle W? Now, if I look at angle W, you have to think to yourself, is that a central angle or is that an inscribed angle? If I'm looking, angle W actually has its vertex at the center. So this is a central angle. And I know the length of its inscribed angle. I know that this measures 31. And to go from inscribed to central, I have to multiply that by 2. So this guy's always bigger. So I'm going to do 31 times 2. Ooh, I'm skipping a step in my head. And I get 62. So the measure of this angle is 62 degrees. Done. So if you're going from inscribed to central, then you want to multiply by 2. So number 2 is the same. So I have an inscribed, right? This is my inscribed. And the measure of angle H is a central angle. So I have to multiply by 2. 61 multiplied by 2 gives me 122. So the measure of angle, ooh, what did I do? There we go. So the measure of angle H is 122 degrees. All right, I'm not going to lie, it does get a little bit trickier, but this is the basics of it. So before we go any further, why don't I try to simplify this as much as possible? So I already gave you the hint. So you have 2 options here. So option 1, you're going from an inscribed. So you have the inscribed and you're looking for the central. You don't know the central angle. In that case, you're multiplying by 2 because the central angle is always bigger. Now, the second option is you could have the central angle. So you have central. Sorry, my handwriting is so terrible. And then you're going to the inscribed. You don't know the inscribed. In that case, divide by 2. All right, so sometimes it's a little bit trickier to find the inscribed and central, but this is the gist of it. This is the basics of it. So I believe we have a couple more examples. Yeah, 4 more examples. We're going to go through all of these together. So if you look at 3, it is a little bit trickier, right? Doesn't look quite the same as the other examples. But looking at 3, it says to find the measure of angle EFG. So I know that you're doing this on the computer and it would be annoying to draw every single circle that you would see every time, but try to mentally highlight what angle they're talking about. So if I'm just looking to highlight that angle, why don't I actually use a highlighter? So if I'm looking to highlight that angle, it's angle EFG. So it's EFG. So I'm looking for this guy here, right? So I'm looking for an inscribed angle. So I'm looking for an inscribed angle. So in order to do that, I need to know its central angle. So if I'm looking, I need to know the central angle that maps arc EG. So that means that I need to know this guy, right? And I don't have a number there. So I don't have a number for that guy. And I need to find this guy. But I have a straight line. And that straight line is split into 2 angles, right? So this is where your linear pair comes into play. So I have a linear pair. That's my first step. So you could have some options that look like this. So in order to find the measure of the central angle EHG, I have to do 180 minus 109. Gotta borrow 7. I get 71. So this guy is 71 degrees. Now be careful because you might think that you're done, right? But that's the central angle. Always look at what the question's asking. They weren't angle EFG. So I have the central angle. I'm going to the inscribed. So that means I have to divide by 2. So I'm just going to do 71 divided by 2, and I get 35.5. That's my answer. You can get decimals. Decimals are okay. All right, so a little bit trickier, but anytime they give you something that looks like this, and let me erase kind of all the nonsense that I drew in. Anytime they give you something that looks like this, the steps will always be fairly the same. You just have to make sure that you're looking at the right angle when you go through the steps. All right, so why don't we try the next one? The next one's a little bit easier. So if I look at this next example, reading the directions, it says, find the measure of angle VUW. So I want to find the measure of angle VUW, so this guy. So that means, again, I'm looking for the inscribed angle. Oops. Looking for the inscribed angle. So when I'm looking for the inscribed angle, I have to divide by 2. Luckily, I already have my central angle, right? Looking from W to V, I have this central angle of 137. So I'm going to do 137 divided by 2. And I'm plugging it in the calculator right now. And that would give me 68.5. So this is 68.5 degrees. So this one, number 4, is kind of the opposite of 1 and 2. So you could be asked simple questions like 1, 2, and 4 that we just did. 1 and 2 is going from inscribed to central, so you're multiplying. And then 4 is going from central to inscribed, so you're dividing. All right. And then we have these guys. So at the surface, these guys seem a little bit more challenging because you've got a lot of lines going on. There's a couple numbers going on. It's a little bit more confusing, right? But it's not too complicated. I want you to think back to section 10.3 because that's going to be very important here. So I want to find for number 5 the measure of JIK. So I'm looking for this inscribed angle, JIK. In order to find this inscribed angle, same kind of concept, I need to know the central angle that corresponds to it. So I need to know the central angle that involves J and K. Well, that has to be JHK here. So I need to know this guy. I don't know this guy, right? But I can find it. So maybe it would help. I'm not the best drawer, but maybe it would help if I kind of drew the circle separately so that we could look at it in a simpler way. So if I'm looking at this circle, I could be asked a question like this in section 10.3. I'm looking at this circle and something like this. Excuse how terribly I drew it, but it's something like this. And then you want to find this. You don't know this. You'd follow the same steps from 10.3. You have 2 angle measures. I have 147. And then I have this right angle box, which means this is 90. So I'm adding 147 and 90, just like from section 10.3. Do 7, and then 9 plus 4 is 13. So I've got 237. That's not my answer, right? That's what the other portion equals. In order to find my answer, I have to do 360 minus 237. And if I borrow, 10 minus 7 is 3, 2, and 1. I get 123. So now I know this. I'm almost done. I'm still not done yet, right? A couple more steps involved, but now I know that this guy is 123 degrees. So now I have the central angle that corresponds to what I'm looking for. To go backwards, to go to the inscribed angle, I have to do 123 divided by 2. And 123 divided by 2 is 61.5 degrees. So that's what this whole angle here equals, 61.5 degrees. So it involves a little bit of visioning only what you need to see, not everything. I don't know if that makes sense. So let's try the last one together. And I actually just thought of an idea of how we can kind of visualize this a little bit better. So I'm trying to find the measure of angle TSU. TSU. So that's this angle here, which again is an inscribed angle. Now, in order to find the inscribed angle, I need to know the measure of the central angle that corresponds to it. So the central angle that corresponds to it would be the angle that has endpoints at T and U. And that would be this guy, TVU. So I need to know the measure of angle TVU. And I don't know it yet. So I have to find that first. So in order to find this guy, what if I go like this? So in order to find this guy, we need to use our concepts from 10.3, our knowledge from 10.3. So what if I kind of just ignore everything that I don't need? I don't need this right now. I'm just going to ignore it. I'm actually going to get rid of it. And I know you can't do that on the IXL, but if you visualize it this way, it might make it a little bit easier. So I'm just getting rid of everything that I don't need right now in order for this step. So first I have to find the measure of angle TVU. This is the same steps as 10.3. I'm adding what I have. I have 110 and 124. So add 110 and 124, and I get 234, and then subtract that from 360. So I get 126. So now I know this guy. This guy is 126 degrees, right? So now I'm going to bring back those lines that I need in order to solve the problem. Now that I kind of just ignored them for a little while, I physically ignored them here. So now I need to know the inscribed angle, TSU. That corresponds to this guy. So since it's inscribed, I'm decreasing in size. Got to divide by 2. 126 divided by 2 is 63 degrees. All right, so that's this lesson in a nutshell. It is a little bit more challenging, I'm not going to lie, but it's doable. It's definitely doable. And I want to put you up to that challenge, but I want to be fair. You're home, a lot's going on. So I want you to complete U9, but only to 60%. And it doesn't take very many questions to get to 60%. I think I was around, I don't remember, maybe 8 to 10 questions in order to get to 60%. So it wasn't too bad. If you feel like you're still struggling, you're still confused, try it out. Give it like 10 to 20 minutes on IXL trying it out. But if you don't get to maybe 30 in that 10 to 20 minutes, please, please, please just put it down. Pick up Remind, pick up your email, and shoot me an email, and we can work through some of it together. I don't want to stress you out. I don't want it to be harder than it needs to be. All right? So that is all. And please reach out if you have any questions at all. Thanks, guys.